The next topic, oxides and hydroxides. Oxides and hydroxides of first group elements. Here, first if you are taking lithium with oxygen, it forms Li2O. Lithium monoxide mainly. Sodium with oxygen, it forms mainly Na2O2. Potassium, rubidium, cesium with oxygen mainly forms KO2, RbO2, CsO2. These are called as superoxides. So lithium forms monoxides, sodium forms peroxides, and potassium, rubidium, cesium forms superoxides. And one more important point, lithium peroxide or sodium superoxides, if you are taking, they are unstable. Here lithium forms monoxide, sodium forms monoxide and peroxide also. It is forming Na2O, sodium monoxide, and mainly peroxides. Whereas potassium, rubidium, cesium superoxides are present. Why we are not taking LiO2 or NaO2, sodium superoxide, lithium superoxide, why we are not taking? Here why means these superoxide ions are bigger in size, they can be stabilized by the bigger cations only. As lattice energies if you are taking, the bigger cation always stabilizes bigger anion, and so superoxides of potassium, rubidium, cesium are only stable. Lithium and sodium monoxides, peroxides are only stable. Okay, that is main and important point. When monoxides and peroxides are taken, here monoxide means suppose Li2O, and peroxide means suppose Na2O, and superoxide means suppose KO2. These monoxides and peroxides are actually colorless because there is no free electron, whereas in superoxides they are colored, orange colored or yellow colored because of the odd number of electrons. This is paramagnetic. Superoxide ion is paramagnetic because of odd electron. And here lithium monoxide when dissolved in water, what is formed means LiOH, or we can write this as Li plus and OH minus. Whereas sodium peroxide is dissolved in water, then it is forming Na. Here sodium peroxide is taken, so we will get NaOH plus H2O2. Sodium hydroxide and H2O2 is formed. 2 NaOH and H2O2 is formed. If superoxide is taken, when superoxide is used, then we are going to get KOH plus H2O2 plus oxygen. And while reacting or while remembering, how to remember means, here 1 mole, it is 1 mole. Then it is giving 1 mole of LiOH. Here 1 mole react with 2 mole to give 2 NaOH, and H2O2 is the extra compound what is formed here. Whenever 2 moles of KOH and KO2 and 2 moles of H2O react, again 2 KOH, all are giving hydroxides commonly. Here extra is hydrogen peroxide, here extra is hydrogen peroxide and oxygen. So monoxides gives only hydroxides. Peroxides gives hydroxides and hydrogen peroxide. Superoxides gives hydroxide, peroxide and oxygen also. The next important point, solubility. Solubility of first year group compounds. Here suppose if you are taking sulfates we are taking lithium sulfate Li2SO4 to cesium sulfate CS2SO4, the solubility increases. Next, carbonates. lithium carbonate Li2CO3 to cesium carbonate, and bicarbonates. Here bicarbonates means sodium bicarbonate we will take, because lithium bicarbonate is not present in solid state, it is present in liquid state only, and it is unstable compound also. Sodium bicarbonate to cesium bicarbonate, the solubility increases. And next, hydroxides if you are taking. Hydroxides. Here hydroxides also. Lithium hydroxide to cesium hydroxide, the solubility in water increases. Here this is the simplest way. All these are increasing only. Please remember, all these are increasing only. Hydroxides, bicarbonates, carbonates, sulfates, solubilities increases gradually. How to remember this means, you simply remember only one point, mainly one point is, what is that point is, cation and anion size difference. Size difference is more than solubility is more. Solubility is more. Okay. When cation size and anion size difference is more, solubility is more. When the difference is less, solubility is less. Means larger cation, smaller anion, or bigger anion, smaller cation. Next, some compounds of first group elements. This first one is washing soda. Washing soda. Here this washing soda is also called as Na2CO3. Actually, the hydrate form Na2CO3 10H2O is called as washing soda. Sodium carbonate decahydrate is called as washing soda. How we can prepare by this washing soda means preparation by the Solvay process. Solvay process is used for the preparation of washing soda. In the Solvay process, first step is ammonia reacts with water and carbon dioxide, and it gives ammonium carbonate. Ammonium carbonate is formed. This ammonium carbonate again reacts with water, and carbon dioxide to form ammonium bicarbonate. NH4, two molecules of NH4 HCO3. Ammonium bicarbonate is formed. This ammonium bicarbonate reacts with NaCl or brine solution, then it is converted to ammonium chloride plus sodium bicarbonate. So this is actually the first product and important product. This sodium bicarbonate on heating to high temperature, it converts into Na2CO3 plus H2O plus CO. Sodium bicarbonate is converted to finally sodium carbonate. That is the preparation of sodium carbonate by Solvay process. Here an important byproduct ammonium chloride is present, and this is treated with the calcium hydroxide. Then it is forming CaCl2, another important byproduct, and NH3 plus H2O. This ammonia is again used in the first step. That is also called this step is also called as the regeneration of ammonia, which is used for the again some Solvay process. This is a Solvay process for the preparation of sodium carbonate, and here ammonia is regenerated. The reverse reaction of the last one means sodium carbonate Na2CO3 plus H2O plus CO2 is used in the preparation of sodium bicarbonate. This is also called as baking soda, which is used in the preparation of cakes and the pastries. We can use this baking soda. So please remember how we can prepare baking soda means sodium carbonate when diluted and passed through the carbon dioxide gives sodium bicarbonate. Another important compound is sodium hydroxide, which is also called as caustic soda. Here caustic soda, why this is called as caustic soda? Because of its caustic property. Whenever it is falling on skin, it breaks the muscle proteins. It breaks the muscle proteins and make it as a pulp. So that property is called as caustic property, and so this is called as caustic soda. And in the soap industry, the raw material is sodium hydroxide. This is prepared by using Kastner-Kellner method. By using Kastner-Kellner method, in this Kastner-Kellner method, we are taking the brine solution. Brine solution is taken as an electrolyte. Brine solution means it is 10% NaCl solution. This 10% NaCl solution is taken as an electrolyte, and here carbon anode and mercury cathode is taken. Mercury cathode and graphite rods or carbon rods are taken as anode. And this is also called as mercury cathode method. And in this process what happens is, first NaCl by the electrolysis process converts into Na plus and Cl minus ions. And here Na plus ions are taking one electron and it is converting into sodium. Here cations, so they are moving towards mercury cathode. And here Cl minus, by losing of electron, it is converted to Cl2, and at anode we are getting chlorine as important byproduct is formed. Here mercury cathode and sodium, they are combining, so they are forming an amalgam. Amalgam means any metal reaction with mercury, the compound formed is called as amalgam, and the oxidation state of sodium in amalgam is 0. Important. Here any amalgam, the oxidation state of an element is equal to 0 because it is not an ionic compound, it is only amalgamated. Okay. And here this is treated with water. Now it is forming NaOH plus half H2 plus mercury is released. Again that mercury will involve in the mercury amalgam formation, sodium amalgam formation. This is the preparation of sodium hydroxide. This sodium hydroxide is also called as caustic soda.